Hey, so welcome back to our notes on increasing and decreasing and constant intervals. In example 2, we're looking at the intervals where two piecewise functions are increasing, decreasing, and constant. Remembering that these intervals are the x values over which the y values are changing. So if you tend to get mixed up about which ones to look at, you could always cross off these y values so you don't get distracted by them, and then we can start reading our graph from left to right. So starting at negative infinity in the x direction, here we see the graph is decreasing until I reach x equals positive 1. So from negative infinity to positive 1, we have a decreasing interval. Okay, then continuing on from left to right, from 1, where we stop decreasing, we see a horizontal segment here, so the function is constant from 1 until at 4, where it turns and starts increasing. So this interval from 1 to 4 would be where the function is constant. Okay, then at x equals 4, we turn and the function is going uphill or increasing now until x equals 8. So the increasing interval will be from positive 4 to positive 8. And then at 8, we have another relative maximum here where the graph turns direction from increasing to decreasing, and we're decreasing from 8 to 11. So 8, 11, non-inclusive. And since there are two intervals over which this function is decreasing, I join them with a union symbol. Okay, so go ahead and pause the video, give example B a try on your own, and when you're ready to check your answer, you can resume. Hey, so welcome back. Hopefully you took a couple moments to try example B on your own, and we'll go ahead and check the answers together here. So we can see from negative infinity until negative 4, the function is increasing. That would be this segment right here. Okay, then from negative 2 to 0, so in my x direction, there's negative 2 all the way up to 0. That interval, negative 2 to 0, would be right here on the function. We see that it's also increasing there. Okay, intervals where the function is decreasing, 0 to 2. So here is 0 to 2 in the x direction. The function is going downhill. And then from 4 to infinity, so here's my x equals 4, and then off to positive infinity in the x direction, right? We can see the function is decreasing over that interval. And then where it's constant would be negative 4 to negative 2. So here's negative 4 to negative 2 along my x-axis, and we see the y values are constant. And then from 2 to 4, same thing, 2 to 4 on the x-axis, we see that the y values are constant there as well. Okay, so the next page of the notes, we have some error analysis where we want to identify the errors and explain them and correct them for these examples. So this person has that the interval of increasing is negative infinity to 3. But when we follow the part of the function where it is going uphill, we see that it's increasing from negative infinity, but not the y value of 3. Remember, we use the x values for intervals of increasing, decreasing, and constant. And where it stops increasing is at x equals 1. So the error is that the person used the y value, right? And we should use only x values for our intervals of increasing, decreasing, and constant. So this should have been the interval negative infinity to 1, right, instead of negative infinity to 3. Okay, the interval where the function is decreasing then has the same problem, right? We're decreasing from 1 to infinity, not from 3 to infinity. because we should be using x values only. Okay, in example 2, we see that we've got a square root function here. Its endpoint is located at -3, and it is heading off to positive infinity in both the x and the y direction. So -3 is the correct lower bound, infinity is the correct upper bound. However, remember that we only use parentheses, right, not brackets, when we're doing intervals of increasing, decreasing, and constant. So this should be parentheses only, right? No brackets. So we would represent the interval where the function is increasing as -3 to infinity, non-inclusive. Okay, then in example 3, let's got moved over there. There we go. So in example 3, we see that the function is increasing from -infinity, because we always read left to right, so -infinity until -1, right? And then it starts increasing again here at 1 until positive infinity. But when we look at the interval that was listed, the person wrote it as 1 to infinity and -infinity to -1. And so do you see how these intervals are out of order? Because we have to read the graph from left to right. They have to list the intervals in order from left to right. So this should be written as -infinity to -1, union, and then 1 to infinity, right? And this reason would be we should be reading the graph from left to right. And then decreasing, we see the function is decreasing from -infinity to 1. So again, this interval is backwards. It should be going least to greatest because we're reading from left to right. So it should be the interval -1 to 1.